Hello, everybody. Can everyone hear me well? Okay. Never mind. Let me try this again. Hello, everybody. Can everyone hear me well? Okay, okay. All right, that is good. And with that, let's start our COE 691 tutorial. Welcome, everybody. In case people don't know me, I'm Caleb. I am also a third year at TMU, and I study, well, the software side of computer engineering. So today we will be uh, reviewing the concepts we have learned in COE 691, and there is quite a lot. And uh, and feel free to leave a message in the chat telling how you find this course so far. I find this one rather interesting, and I will leave the word interest. I will leave the definition of interesting uh, up to your interpretation, I guess. So, without further ado, let us begin. So, the agenda for today's tutorial revolves around five really huge concepts. We start with some introduction to what software engineering is. We also look at software development lifecycle. And let me test to make sure that nothing is crashing on my OBS. Okay, yeah, that looks good. So after the introduction, we have the requirements engineering. So we take a look at like the pretty much like an overview of this discipline when we engineer, when we like create products. We do place a bit more focus on software, however. The next concept we have is requirement inception and elicitation. Then we will take a look at inside the elicitation step, the techniques used in elicitation. And finally, we will also look at requirements prioritization. This will also include how to deal with conflicts. Let me just move some windows on my Zoom to the other side of my screen, to my other display. Okay. And of course, for your reference, I would like to thank Jasper Cruz for your notes. And I will post these slides onto the Google Drive like last time so that you can take a look at his notes for reference. And of course, make sure you watch your hands so that you don't develop carpal tunnel syndrome. And without further ado, let's take a look at our first concept, which is the software engineering and software development lifecycle. From here on, if you have any questions or you need something to be clarified, just let me know either in the chat or through your voice by unmuting your mic, and I will happily answer whatever question you have. Okay? Right then. So, software engineering and the software development lifecycle, we have kind of learned this in COE 318 as well, which is software systems. Just a little bit though, not too much, because that course focuses on implementation. So whenever we do software development, we go through quite a few phases. In our case, we have the requirements analysis. We have then we draw out a design, and then we start. And when we finish the design, we start coding or implementing the system, then we test it, and finally we deploy it, and the entire process repeats. Okay, so that is a really basic way to look at it. And if we take a look at other courses, we broke uh, down the same set of activities into these steps. And first, we have already taken a look at how we do implementation and testing in COE 318. That is a second year course in your third semester, I believe. Next, in the fourth semester, which is your second year, maybe in the basically in the second semester of your second year, we have taken a look at uh, how we further create detailed designs of our software in COE 528. So yesterday, we have taken a look at systems design through COE 692. And now we're gonna address the really first step before everything else happens, which is COE 691. So in when we deal with software development, there are different ways you can go about it, uh, and we may and the way we conduct software development can can be categorized into different patterns, like can be put into patterns, and we call these process models, like SDLC models, and there are many different kinds of models we work with today. So we have some that are traditional and some that are modern, which are pretty much like the newer ones that work in the present day. So let's take a look at some traditional ones, starting with the most basic, called the waterfall. So, I mean, imagine you try to like swim to the edge of like Niagara Falls, which is really really tall. Um, and you just like I don't know, just go down that huge waterfall. That is the waterfall model. The way the waterfall model works is that each stage is linear, and you only go to the next step after the previous one is complete. So you start with requirements, just do everything you can to perfect the requirements. Then you jump into the systems design without looking back. And then you repeat for systems design, implementation, integration, and then maintenance. And then you have basically when you go to the maintenance stage, you'll be in rock bottom and you're just gonna be stuck there. And it feels more natural, yes. And the stages and the phases are independent and because like we separate them so that they are distinct and they do not interfere with one another. Each phase, you can mark each phase as a milestone. So administration or management would find this really easy to work with. The thing, however, is that if we purely use the waterfall model for the entire system, these steps are rather inflexible. Like sometimes you may want to interweave a couple of things into one step that, like the waterfall model doesn't really allow that to happen. Um, and we have also the problem of requirements that keep on changing. So when requirements rapidly change, adapting to those changes using the waterfall model is really difficult. And of course, this model only works if you have really well-defined requirements and those requirements don't change much over time. Like it can adapt to a little bit of changes, but not big ones. So because the waterfall model is way too rigid, we're gonna look at other models, um, like like other models that are made for different purposes when it comes to maybe dealing with changing requirements or requirements that we are not really certain of. The first one we have is the prototyping model, where you do a mini waterfall. You just keep on doing it until you get a clear enough uh, idea of the requirements of your real or your final system. So once you're done like building the mini products called prototypes, you just go down the waterfall the same way. But this model allows you to go back though. So like it can be combined with some other model when you're ready to when you have like well-defined requirements and you're ready to you're ready to start making the production system. Okay, like the final system itself. Of course, this prototype is not without its downsides. So because you're just making different small versions of the same product, you are pretty much it's pretty much costs quite a lot of money, and it may also take a lot of time as well. And another thing you have to be careful with is that when you're identifying like key issues in your system, make sure you are careful with which ones you identify, because if you miss out some high risk issues, the prototyping model is not really good at like telling you that. So you may have a false sense of security, and once you make the final system, you may miss like some potential vulnerabilities, and bad actors will just put your like will just run your entire system into the ground. Okay, so we have the prototyping model. Now we have the iterative model. It's a combination of the traditional waterfall model and prototyping, where you have um, where you create your system, um, like one feature by feature, or people would say incrementally, I think. Yep. So you pretty much like run in your first iteration. That's why the model is called the iterative model. So in your first run of the waterfall, you define like a certain feature, or maybe you start documenting the requirements of the overall system, and you start developing one feature. Then when you're ready to release this feature, you just deploy it. Excuse me a moment, I am a little bit thirsty today. Um, like right now, not just today. Um, and then when you're done with like one iteration or one feature or update, you do the next one, which is your second iteration. You design that new feature or design that new update, and then you run through the waterfall again. Uh, Feel free to also like review your previous feature and refactor it if you need it, of course. This model does allow a little like some methods of going back and revisiting old things. And when you're done with your second update, you're gonna move on to the third, and you're just gonna keep on going. It's like jumping down the waterfall, like maybe swimming all the way down, and then you climb back up again, and then you go all the way down again as many times as it takes until you feel that that's like your adrenaline needs is satisfied. To be honest, like I don't think anyone would like to actually like go down Niagara Falls, because again, it's a really tall waterfall. You really don't want to get injured there. Um, So the good things about the iterative model is that it does allow more opportunities for user feedback. So you push out an update really really quickly, and then the users will come back with like valuable feedback for certain features. And if you keep on doing it, you will get an overall like a nice quality system, and the users would be happier. The thing is, if you do if you do the develop if you development oh sorry, let me try this again. If you try developing the software iteratively, your design might not be optimal. So so if you have to end up going back and refactor certain things, it's gonna cost a whole lot of money, and no one likes to spend more money than they should. And um, one more thing you have to be careful with, if you're stuck in one iteration, um, you're gonna need to consume more time, and new updates might take longer as well. At least that's how I see it. But that only happens if you do one iteration at a time. So to combat this problem, we have the time boxing model. So the time boxing model is like iteration. It's like the iterative model, but you can actually you put a fixed time frame onto each iteration. There are two ways you can do this. You can do one iteration at a time, or if you want to distribute the duties to more people, you can try running the iterations concurrently. Yes, concurrently. So if you look at the bottom right diagram, you can actually have like updates number one be you can have the updates number one uh like just starts whenever they're ready, and then maybe one third of the way into the first development, uh, the second development can start working together with the first and build the next updates features, and then similar things happen for the third and fourth iterations. So that way your delivery times are shortened because we're not doing things one iteration at a time anymore. We have multiple iterations going on at the same time. But this also introduces a problem of synchronization, because sometimes maybe one resource depends on another like undeveloped resource, and that means the teams involved would have to synchronize. So if you're running this time boxing model, you're gonna need to synchronize your teams, and you have to be careful not to throw any team off track. So if you want to do concurrent time box, this like maybe make sure that your project is not too big and your teams are not large, because the time boxing model is not really made for that. But the great things about this model though is that it is flexible, and at the cost of more manpower, you can shorten your delivery time and release your software to your customers as soon as you can. Okay, so now we have covered some of the traditional models, so let's take a look at some modern ones. We have the good old agile model. We only covered this model, but the agile model can actually be split into a multitude of other models. So you can have some examples are extreme programming, Scrum, Crystal, and the one I worked with in one of my internships is Kanban. So if you have used Trello before, you're actually running your project under a Kanban model, and it has its good things. So in Agile model, you just basically run your iterations in loops. So pretty much you're trying to deliver deliver like your feature like as quickly as you can. So like deliver mini features, really small features. You work in small and short increments, and instead of iterations, we now call them sprints. So you keep on doing this and you keep on deploying, and this really helps because running things in small increments allows you to adapt to changing requirements more easily, as opposed to like larger iterations. And it makes collaboration easier, because teams just how do I say this? How do I say this? Okay. Feel free to let me know about collaboration in agile models as well, because I actually kind of forgot maybe it just like they just put it they just didn't like pop up in my head, but yes, agile models allows teams to collaborate like more closely together. I think that is what it is, and thus making collaboration easier. Ooh. The thing about agile model though is that uh, like progress tracking becomes much more unpredictable, and your released product will not be in its final state. So it's definitely not gonna you're not definitely releasing your final system. You're gonna keep on updating it as you go. And finally, because of how fast-paced the agile model is, you might your documentation will lag behind a lot, and this is the part where like developers should highly maintain, because no documentation, people won't know what you're doing. Simple as that. Okay, so that is all of the process models processed. The next thing we have is requirements engineering. So we're getting into like the more core parts of the course. So like so some of the concepts do take a whole lot of slides. Um, don't worry, they're pretty short though. So there are different activities that we do in requirements engineering. Uh, we start with inception. Then we start with inception, taking a look at like whether there is a new business need or a new opportunity to create new projects and so on. And then we deal with the development of the requirement. So that involves elicitation, analysis, specification, and then verification. And finally, as you develop your requirements, you may have to change them, and so that is where requirements management comes into play. Okay, we're gonna take a look at all of this, I think, throughout the entire course. But right now we have touched on like I think a few of these in really good detail though. Okay, so there are different types of requirements. Wait, let me try this again. Okay, so you can actually put requirements into three categories. You can have business requirements, user requirements, and software requirements. So in business requirements, we take a look at why the business we are working with needs this product out in the open or out to the public. So when you're documenting business requirements, you pretty much describe the tasks of what the system needs to do so that it can generate value for the business. For example, what will help increase the market share? Um, or maybe a system that will improve a process and make everything run more efficiently. Or maybe you want to give like mobile access to customers' accounts, making everything more convenient. And there are more examples you can think of. I'll leave that to you. So the important thing about the business requirements is that success of the project will depend on whether these business requirements are met. So make sure you take good notes of them and see if everything and that way you'll be able uh, to keep everything on track as you go and develop your product. By the way, one reminder, people, make sure you keep yourself hydrated. Okay, next is user requirements. So we have for user requirements, we look into what the users will do with the system and what they expect when it comes to how the system will respond. For example, the user should be able to look up account balances and their transactions. They should be able to maybe schedule an appointment by clicking a few buttons. Maybe they should be able to pay by credit card, or they should, or for the people using an inventory app, they should be able to update their inventory, like ordering more inventory, like or items in the inventory, or making new products, or making new inventory items. So software requirements is pretty much like the requirements of the software system itself. You can split these into two groups. We have the functional requirements. These are what the system is designed to do. And we have looked into functional requirements a lot through making use case diagrams and if you're taking COE 692, I assume like all of you are you have dived a little bit into functional requirements before when you're making your project. Non-functional requirements, we did not really get into a lot of it, but they are equally important here in this course. So non-functional requirements, they describe like specific attributes of the system, like runtime, like uptime, maybe some specifications of security, for example, SSL, bcrypt, and so on. Uh, these requirements detail how the system fulfills the functional requirements. Like they answer the how, not the what. And for these requirements, like it would be nice if you can achieve them. Like it would be nice, but they don't not you don't have to achieve all of them. Like they're there to make sure that like the system will perform the functional requirements as best as it could. Okay, so for the people who have joined in late, feel free to ask me a question as we go through the concepts we're reviewing tonight, and also welcome. I hope you enjoy your stay. Okay, so let's take a look at if these requirements are functional or non-functional. So let's start with this. Okay, let me try this again. Hang on. So, first requirements we have here is that users can click on sign up with Google to sign up with their Google accounts. Feel free to type in the chat your answer if you would like to play along. So is this functional or non-functional? Okay. So for the people who would like to keep the answers to your head, that's okay too. This just acts as a nice little exercise for your brains and all. Okay. So the next one is user passwords will be hashed with bcrypt. I'm not sure if I phrased this correctly though. If you have non-functional, that is correct. This is like if I were to be making this a functional requirement, I should be able to say the system should be able to the system can store user passwords securely. Okay, because this one is actually answering the how. How are you going to store your password securely? Well, you're gonna hash it with some library like bcrypt. Okay, yeah. So this should be a non-functional requirement if I phrase this correctly. But feel free to if you disagree with that, feel free to let me know as well because not everything is black and white here. Sometimes, well, not everything. Next is enterprise accounts can request to use processors of higher tiers. Feel free to type in the chat whether this is functional or non-functional. I'll give you some time this time because I think I rushed a little bit too quickly. Okay, the next thing, this requirement is actually answering the what. So you're actually answering like what can enterprise accounts do in some hosting in some cloud application platform like AWS or Google Cloud. So this is a functional requirement. The next is the host can host videos of up to 4K in resolution. This one, actually, now that I think about it, like I actually put non-functional for some reason, and I have n- and I'm thinking of changing the wording of this because this really makes it sound like answering the what as opposed to the how. So this one I'm a little bit hesitant on why I put this as the answer, but feel free to let me know your thoughts on it. I somehow put non-functional during the time I made the slides. Okay. Um, and finally, this one is this one is pretty clear. The app should be able to service more than 1 million users concurrently. So, um, okay. So I guess like when I wrote this, I also wrote non-functional. I think there is a picture I would like to show you for this one. So let me take a look to see if I can dig it up. Because when I made this, I do made a little I do referred to something. Let me see if I can like take a look at this, and hopefully I can like bring this to you as soon as I can. Okay. Um. So hang on a second, people. Let me just duplicate the slide. Now it's okay if you all disagree with like what I'm doing as well. Um, just make sure you let me know as soon as you can, and make sure that you respect people. That's about it. So let me make sure that this thing works. There you go. Okay, and let me make sure that OBS is capturing this. Yes, the OBS is capturing this. So this is how the third column here is how I pretty much what I refer to the thing from. So hang on a moment. I actually made this thing a non-functional requirement um because I think I'm supposed to write like users can like the service can service more than 1 million users at a time, like 1 million logged in users at a time. So this one deals with a little this deals with this one I would say lean non-functional. But yes, feel free to let me know how you interpret this as well, because I may also change up the answers too. So that's pretty much the thing about functional versus non-functional requirements. I'm gonna include this picture into the slide so that you can take a look at it as well. Okay. So yeah, non-functional requirements are also known as quality attributes. We have so the typical non-functional requirements can be put into different categories. We have usability, which is how easy it is to use the system. Dependability, which is how trustworthy it is. Reliability, basically like like how consistent the system is. Like, can I trust it so that it can keep on like doing its stuff no matter when I tell it to. Robustness is like how strong it is, or maybe how tanky it is, uh, and how well it handles invalid input or stressful conditions. Safety is how likely the system is to experience catastrophic events. Uh, More like how less likely. If I have to phrase what safety is. So you have to build a system so that it can handle really bad. It can like avoid really bad security incidents. Okay, so let's take a look at how we can identify non-functional requirements. Um, we can split up the requirements into different tasks. So you start off with one requirement, break it into different tasks you can identify, and then break each task into subtasks. You're gonna keep on going until you are able to identify the quality attribute of the subtask you're looking at. Then, after you're done breaking things down, you can decompose one of the attributes you have identified into different specifications that will meet the goal. Ishan, is this recorded? Yes, this whole Zoom thing is being recorded as well. I'm also recording on OBS. So yes, it is recorded. Oh, yes, just to let you all know, these notes are being posted as well. The next thing is this is a sample diagram of of how we break down requirements. For example, if I were to make a to-do list, I can create a new list and save changes. And when you create a new list with or without an account, you may want to be able to you may identify some aspects within it. For example, like how easy is it to create this list, and how fast can it perform, um, how fast can it handle my request to create the list or modify it. And also for maybe when you create an account, you want to be able to securely store this account so that like hackers won't be able to steal your info. I will leave this diagram to you so that you can take a look at the breakdown whenever you need. And now, wow, I really love the way like the smart art morphs like one diagram to the other. Now if you go into security, maybe into security you may want to have to comply to some specifications, like maybe you want to include SSL into it. uh, Maybe you want to make sure that your app your app complies with data confidentiality laws. You may want to make sure that you have a really strong password policy, uh, and so on and so forth. So we have taken a look at how we identify non-functional requirements, and we also have taken a look at functional requirements a little bit as well. So let's take a look at how we model them. So you can use models to communicate the problems and uh, solutions, or communicates the requirements we managed to draft to people who are not technical, like reviewers and stakeholders. There are three types of models. There are the textual, graphical, and mathematical. So for textual modeling, you just put everything into words in a nice written down document. Natural language does have some limits in the fact that like if you're communicating one thing to another, you some information may be lost as you go down the chain. Of course, unless you're quoting somebody in an email, that's where in that case you won't miss anything. But if you're using just natural language, just talking and like writing things down, some things might be lost. Graphical modeling allows you to put everything in pictures, and for people who like to visualize the things, this really helps. Here's an example of like maybe some uh, maybe something about artificial intelligence, like detecting wet grass, or maybe the system like trying to detect like the car dying. And finally, we have the mathematical modeling, which uses equations, formulas, statistics, and algorithms. Yes, algorithms are indeed a form of math, and we have indeed like written different algorithms for different problems before. Now, an example of mathematical modeling with equations is this thing that I've actually shown you. If this gives you a little bit of trauma, I am really sorry. This one actually came from like analyzing circuits involving bipolar junction transistors or BJTs, and it calculates the collector's current. A really simple formula, but it does bring back some really stressful memories. That includes me as well. And when you're dealing with modeling, you may cater like your models to like one requirements, and then you can layer one requirement after another. So for example, you may have some requirements, and then you build a nice model on top of it, and then you add more, and then you build more, and so on. So you can actually make a sandwich out of this, which is pretty cool. Okay. There are different approaches to system development, or rather, this is like software modeling. There's the structured and object-oriented. So for the structured approach, we think of a system as a set of processes. Like it sounds pretty natural, like in one way, but in one way, and uh, and you can actually model with this approach using the data dictionaries, data flow, and entity relationship diagrams. So this approach does help breaking things down into multiple steps. So multiple steps, multiple processes, and and that's about it. I think we have dealt with something similar uh, when we're designing an application that involves relational databases as well. Who knows? Like there are different components to your application, and they do different things, and so they count as different processes indeed. So uh, the other approach, which is the object-oriented approach, describes the system as a collection of different objects interacting with one another. Hang on a moment. Let me just go ahead and fix a typo over here. There you go. So objects send and respond to different messages and events. This is reusable, and it actually sounds more natural because we do see the world as like a whole lot of different objects. I don't know. You can fill a coffee cup. You fill in a coffee cup. You set an alarm, and so on and so forth. You can model this approach using class diagrams and sequence diagrams, to name a few. Okay, we're done with requirements inception and elicitation. What is the time right now? It is 6:55. So we're actually doing pretty well. Um, so requirement solicitation, there are like 10 steps to it, and unlike certain D2L midterms or D2L exams where you cannot go back, you can actually go back and forth in the requirement solicitation process. So let's go through some of them. And before that, I also introduced. I would like to introduce to you the requirements engineering lifecycle. So, uh, you have elicitation, which is like start, which is the start of gathering requirements and so on. Um, and then you analyze the gathered requirements, like breaking them down into smaller pieces, or like resolving like inconsistencies or conflicts. And then you start documenting your requirements through the specification process, and then you evaluate those specifications to make sure that they meet your needs. So of course, this life cycle is not really how to say it. It is not really like it doesn't have to work like one by one. You can have some overlaps, a little bit of iterations in between. And this life cycle is an ongoing process, so you keep on running the loop as long as requirements keep on being refined and updated. So how do we perform requirements inception? So first you define the scope. What does the system do? um, what does the system do? What are its boundaries? What features we can we include? Then we have a feasibility study. So can we do this? Like, can we realize the system? Uh, that decision will depend on the technical, economic, and operational factors. And finally, and also we have to take a look at who this system is catered to, and people who have high interest in the system. So those we call them stakeholders. Stakeholders can be individuals and groups, or even large organizations. And how do we put everything in during requirements inception to paper? Well, we work with these artifacts. The first one is like outlining the business case. Actually, now that I realized, my face is in the way. Come on, there you go. So we have the business case, which is an outline of what the business needs. And then we will work with use case models to visualize and describe key features and requirements. And finally, we will list the risks involved with the system, like maybe there are some like le- uh, related things that you need to be aware of. Maybe some system may injure somebody or ruin their livelihoods and so on. So before we actually deal with actually making the requirements, like making up the requirements, we need to do a preliminary investigation. So we start by understanding the opportunity or the problem we are working with, and then we can investigate the project scope and constraints. We will also we do some pathfinding, where we take a look at like who is going to use this, and who should have a say in how we make the system. And then we analyze the usability costs, the benefits, and like the scheduling parts of the project. After we looked into those four things, we then sum things up with a feasibility evaluation. There are four aspects like the four aspects listed under this part uh, are examples of what's included in the evaluation. And finally, we present the recommendations through a report. So for fact finding, you may want to use a questionnaire. It's easy to make, and you can cover a wide range of people. However, not everyone's gonna respond to you, and because like the face-to-face, there is no face-to-face when it comes down to questionnaire, so people don't have to respond, or maybe they won't have the time to. The next thing you can do if the questionnaire would likely be not enough um, is the interview, which we will take a look at later. There are different types of questions you can include in the questionnaire. Uh, so you can have like a close-ended question, basically like a simple yes or no, and or some numeric answers. So basically they do provide like definitive answers. Open-ended answers. So they are long, and you may combine multiple questions into one. Those are called compound questions. And the next one, which I'm kind of like erring about, like ERRing about, is called leading questions, which are made to influence the interviewee's answer. So you would most likely encounter them in the "Do you agree?" questions. So the one thing you have to be careful about this type of question is that they do introduce bias. So be careful with these. If like at least maybe create a scale and have people respond to how well they agree with this. And finally, if you want to ask for different examples of something, you can ask a type of question called probing questions. Okay, fact finding. And the next thing in fact finding is called the interview. You can meet with some stakeholders, ask them questions face to face. Although this process does take time and it will be costly, and it becomes more difficult if you add more interviewees across like different parts of the world. So I'll give you a nice little questionnaire like example. To maybe you can start by giving the questionnaires to the people you're about to talk to, or pretty much your stakeholders. Have them fill them out, and then if you would like to, you can even follow up with an interview. You can interview them, ask them about different opinions in detail. Make sure you outline your topics in some kind of agenda so you won't go off track. And after you're done with the fact finding and all the other processes, we're gonna skip over to evaluating feasibility. There are five different factors into determining feasibility. We have the economic. We have the economic aspects, which is this project even worth investing? Will I get good money back out of this, or will this help the company make more money? Uh, Organizational, will users like it? Will they be willing to adapt it to what they've been currently doing? Schedule feasibility. We have it. This one is about the time it takes. So do we even have time to even make this project? Some projects are really take a really long time, sometimes months or even years. Some are really short. It may take a few weeks. The technical aspect is the question of, can we build the system with our existing tools? And finally, the operational aspect is this effective? Like, is this effective? Is this practical? And are we gonna use this in our everyday from the day we finish this system? Another type of analysis you're gonna do is the analysis. If I were to pronounce this acronym like this, so SWOT includes strengths, weaknesses, opportunities, and threats. Strengths we would be taking a look at like what's the business has that the other competitors don't. So that counts as advantages. Weaknesses is what the business does not have, but the competitors do. The opportunities, take a look at like the things that cause the company to make strategies to improve itself. And finally, the threats would be like the things that will endanger the business itself and also its likelihood. And after you're done all the steps, you're going to present your preliminary findings as a report in a report. You can like uh, structure your report this way, and I don't, and that's about it. And that's about it. Like uh, that's the report. There is nothing else I can tell you about it. Like introduction, the systems, like the requested systems summary, like what does the uh summarized like version of what your system's supposed to do. What you find about the different things related to the system. What do you recommend, and also what are the uh, estimates in terms what are the estimated uh, uh, time frame and costs. Okay, we so now we're gonna go into the actual requirement solicitation. There are 5 steps. The first is that you have to understand the dimensions of your system, like of your project. So you have to be able to understand the business, application domain, your specific problem, your needs and constraints, and so on. There are 7 of them. Then you source the requirements from different people like customers, users, or even subject matter experts. You should find a diverse crowd of people so that you will be able to understand like different perspectives and make the system as inclusive as possible. As inclusive of them as possible. Yeah. The next is analyzing stakeholders. So you prioritize your stakeholders based on their interest, power or influence, and their expectations. Make sure you bring up potential conflicts too. Next is you apply certain techniques into your elicitation, and finally you put everything together, and voila, you're done. So when you do stakeholder analysis, uh, you want to identify a few things. Who has interest in this project or issue, and what what characteristics do these stakeholders have? So you have to pretty much know their expectations and background, like where are they coming from. So and finally, you want to be able to take a look at how much influence do they have. Like do they like is their input uh, gonna be a pivotal in the direction the project is taking, or like will this be like we can consider it, and then we ended up not doing it because the influence is too small for this particular stakeholder. Make sure you consider as much inputs as possible though, so that like you can cater to like more users and like retain more and more customers. Okay. Um, so this is a stakeholder register. A stakeholder register captures like all the stakeholders that have interest in your project. You can like take a look at like maybe what they do, what is their role in their project, and you can also document their interest and influence. And also, if you want to add one more column to this, you can add their expectations to the mix. And then you can like list out your stakeholders through a stakeholder ring to identify your to identify your to identify like who you're most likely gonna work closely and who you're gonna keep updated. So this is a an example of a stakeholder ring of a community policing project or initiative, something like that. Okay, so here's the difference between primary and secondary stakeholders. Primary stakeholders do affect the project's success, and they do have high interest in your project. So make sure you listen to them really closely. Secondary stakeholders are not necessarily affected by the project, but they do hold influence, and or they may be influenced by it in some degree. Next, when you're finished with like listing out your stakeholders and like considering their different characteristics, you plot your stakeholders on a power interest matrix. So there are like four quadrants to this. If you go through quadrant one, which is the actually, I'm not gonna say quadrants one, two, three, or four. I'm just gonna stick to the top left quadrant. So the top left quadrant, you just want to keep them satisfied because your that particular stakeholder is has a really high authority or influence, but they are not that interested in the specifics of your project. Uh, going down to the bottom left corner, you just monitor them. You just take a look at how they're doing. See if they react because they have little influence and little interest. So you can consider what they're saying, but you don't really have to work too closely to them. Now, it's minimal effort, not no effort, by the way. You do need to make an effort to also keep them pleased regardless. Next is keeping the stakeholders informed. So those will belong to the stakeholders that are interested in the project, but they don't hold a high authority or power. And finally, you may want to engage and consult the stakeholders that have both high influence and interest very, very closely. Like consult them, engage with them, talk to them as often as you can, and work with them to make sure that like they are pleased. And then when you're managing stakeholders, you may need to come up with a plan. You have to consider like how much engagement you're gonna put into some stakeholders. You may also want to make sure that the relationships between the stakeholders hold a nice hold nice relationships, like not like business relationships, of course. um and then we you may also consider like how they want to be communicated, like what's they need to know, um and like draft out a strategy per stakeholder. And finally, you also need to think about how you're going to update the plan so that when things change, you won't be negatively impacted by that. Okay, so here are some elicitation techniques. So we have so there are two types that we have learned. We have the classical and the modern techniques. So for the classical techniques, they have been used for a long time, and it's actually way before software engineering becomes the mainstream. And for modern, they are made specifically. They are made. They are more recent, and they are more improved, and they're pretty new. So they may apply to like solutions in the present day. Who knows? Okay, so here are some classical techniques. We have already covered the interviews. We have one called introspection. We also have one where you analyze existing systems, and we may also analyze existing documentation. And finally, we use observation and social analysis. So basically, you're putting someone into uh, in somewhere and have them make observations about their behavior. So introspection involves like a business analyst imagining the kind of system that does the required jobs. So basically, we're gonna ask the business analyst to work their brain and think about like what's the system supposed to be able to do and how we can interact with it. The thing is, like, it can be inaccurate, and the stakeholders will have differing goals. So this might not be a good idea. But that's one way to get things started, though. But you may have to flesh a few things out afterwards. Next is analyzing existing systems and documents. So you may want to analyze like business plans, like take a look at the existing documentation to see what they're trying to do, if there are some legal things involved, you also need to look at regulatory documents to make sure that your system is up to the standards listed by the whatever law you're looking at, whatever law you're gonna comply with. So here are three steps that in documents and existing systems analysis. Uh, you evaluate whether the existing thing is appropriate for your requirements, and then you identify like the relevant business details, and then you review and confirm that your identified details are good. Uh, you should you may involve some subject matter experts to make sure that your specifications pretty much make sense. So for observation and social analysis, we there are different types of ways there are different ways you can go about it. You can conduct a passive observation. So like the observer like uh, doesn't do anything. They just like stand there or something like that. Active, you just tell the observer what to do. And then explanatory, you have the users talk loudly what they're doing, like providing gaming commentary on Twitch. And finally, you have ethnography, where you immerse the observer in society. This might be a bit more difficult because nowadays our communities are really diverse and they come from many different backgrounds. So if you need to really do this, do involve maybe psychologists to make sure that's the social requirements in our in being analyzed are understood. Okay, so those are the classical techniques, but we also have some modern techniques that will do the job even better too. So we have seven of these. I will just leave the list here, but for the slide, but we will look at some of them in detail. So one of those is brainstorming, where you have the storm and the calm. Yes, it's called brainstorming for a reason. So when you're actively in the storm, you generate as many ideas as possible, and then you don't really care about the quality of these ideas. You just generate them, put them out. Like I don't know, put them spam them in chat or something. Well, don't actually spam the chats on Zoom, okay? Then we have the calm. So after the storm is over, you filter out the bad ones and keep the good. Okay, keep the good ones. The other method we have is task analysis, meaning like we look deeper into like what this task is, and we divide them into and we break them down the same way as breaking down like non-functional requirements. So here is oh, here is a sample diagram on the right. Okay. Next is joint or rapid app development, which uses the acronym called JAD. So for joint or rapid app developments, like we involve like we involve like people from like a whole slew of key roles, and we determine the requirements together to make a successful JAD session. We can we need to consider some things. These can be used as a guideline, and they're called the 6 Ps. We have the purpose, participants, principles, products, place, and process. However, this approach is not really good if you want to thoroughly make sure that the solution works. But it can involve a whole lot of people, and that's great because you get more inputs that way. Prototyping. We have you create a preliminary version of the solution. We've already seen this during the process model section. So you create a mini product, see if we can figure out some requirements from there, and then we, I don't know, throw it away or we evolve it. There are different forms of prototypes. We have the horizontal prototype where it gives you a broad overview, not much detail in any one area though. The vertical prototype is like the opposite of the horizontal one, where you dive into one specific aspect as deeply as possible. And finally, you have a throwaway prototype where you just make something using simple tools and then you just trash it after you finish implementing the final system. Workshop is a little bit different compared to JAD or joint app development. It's pretty much you're just bringing a group of users and stakeholders, and then you just sit them together and have them work together to come up with the requirements. And finally, we have reverse engineering, where you work backwards, look at an existing product, look inside it, and uncover like what needs to be done in our new system. This is useful in like migration projects, and you have done this in CEN 100, right? Feel free to answer in the chat. Yeah, same thing as well. Yeah, same for me as well. We all have done this in CN 100. So requirements prioritization. So now we're now in the very last thing in before the midterm. So there are different ways you can classify. You can classify and then prioritize your requirements. Um, we can maybe classify your functional requirements by user class. Maybe different stakeholders want something, different customers want something, uh, and you can like then subdivide like some of these classes into more subclasses and so on. Here is an example on the right side. Then we can classify. Uh, we can also classify by feature. Here is like how one would can do it on the right side. When you're classifying by feature, make sure that your feature's description includes like its name, its description and priority, um, its how a user or some kind of system can interact with this, and also its associated functional requirements. You can take a look at like the right side just basically uses. I'm not sure if this is visual paradigm, but I kind of think it is. I'm not sure. I'm not sure what this is, but it does give you it does give you a nice view on it does give you an example view of what it of like classifying by feature. For example, efficient shift change is a feature. Yeah, you have its description and so on. Okay, so we've done functional requirements classification, but how do we do the non-functional ones? So these are a bit more challenging, but there is a framework you can use, and it's called FERPS, or in our case we have FERPS plus. FERPS relate FERPS refers to the five aspects: functionality, usability, reliability, performance, and supportability. So among those five things in the FERPS acronym, we have usability and performance being normally the most important. The plus comes from the fact that it's an extension of the current FERPS framework, where we may include design constraints, implementation, and interfaces. So that's classification done. We also need to think about how we prioritize our requirements. And let me check the time. We are half an hour before we are done here. So whenever you want to prioritize your requirements, what you're doing is that you may have to make compromises, uh, identify trade-offs, and resolve conflicts. There are different approaches you can do this. One is AHP, analytical hierarchy process. So that is where you use statistics and math to have a nice order of priority. Cumulative voting, you just give stakeholders some 100 money or time units, and then you distribute between requirements. Numerical assignments, you just group them into critical, standard, or optional categories, uh, as you discuss with your stakeholders on that. And finally, we do the good old Watch Mojo type top 10 most important requirements. So I actually said Watch Mojo because that is what quickly comes to mind. This is the top 10 requirements approach. Okay, so here's an example of what AHP kind of is. So we start by listing out the requirements we're looking at, and we make an n by n matrix based on them. So n is the number of requirements, by the way. So let's say we have A, B, C, and D as requirements. Maybe it's best that you involve some symbols, if symbols like A, B, C, D, and so on. If you're gonna identify your requirements, so that you don't have to write too long. Okay, so I will start with some matrix. Okay. The main diagonal will have the intensity of 1 because they are the same requirements. So you don't have to do any comparisons. But for the other ones, what you can do is that you pick one of the upper or lower triangles, and then you're going to make n times n minus 1 divided by 2 comparisons. That is actually the number of cells you're going to fill in the numbers in your chosen triangle. So you're gonna compare the row number, uh, the requirements in the row to the requirements in the column. So I is the row and J is the column. Okay. For example, if I compare A to B, so requirement A is not as important as B because B is has an intensity of 3, for example. So we compare that. A is 1, B is 3, so it's 1 over 3. You can take a look at the lecture notes if you want to practice this process a little. Next, you're gonna take the reciprocals of these values and fill in the cells that have their like position indices swapped. Okay, so remember that the reciprocals do apply, and they apply in the other triangle you didn't choose before. And I will like highlight the thing about reciprocals in the red box so you won't forget. So we have filled out the matrix. Now we sum up the columns. We're gonna do an average over normalized columns to determine eigenvalues. I don't really like saying this because MTH I forgot the course for it, which is linear algebra, is giving it does give certain people nightmares, and I don't want to mention too much about it. Um, but it's a first year course. So we sum up the columns. Then, in each column, you divide the cells in that column by its total to get the weight in each column. So, if you want to, you feel free to write a MATLAB code for this, okay? So I've grouped each column into different colors so that you know that which cell belongs to which column. It makes seeing this easier. Then, after you converted your matrix into like after you've normalized this stuff, actually not really normalized, but after you completed this step, you're gonna sum each row. So I made a new column to for the sum here. And finally, you're gonna divide the vector containing all the sums in the order from A to D by the number of requirements. Or, well, it's actually the number of rows. So in that case, it will be 1 over n. So you multiply that vector by 1 over n. And then after you get the results, each like number in the vector is going to correspond with each requirement A, B, C, and D in that order. Now you're going to repeat the same for cost, and then you graph both of them. And finally, you plot the cost value diagram, and you're going to prioritize the ones that are low cost and high value first. And then the medium priorities will have a bit of both. And finally, for those that are low, that have a low priority would have different requirements that are low in value, either very low in value or they are very high in cost, and not a lot of people are interested in it. Okay, so that's an example of AHP. You can look at this on your lecture notes. Requirements. Now we're gonna take a look at how we negotiate and solve conflicts. So here's the thing about stakeholders. They're humans too, and they have something they want to hold on to. So they may uh, wants to defend the requirements they listed and try to dismiss the others that are against them. Um, and and maybe stakeholders want something, but they don't have the knowledge to explain it. Or maybe the requirements like the stakeholders agree to some requirements, but they do conflict with each other, making like making realization pretty much impossible. So here is how we assess severity of requirements. Mutually exclusive means that like if we try combining them, neither party would be happy. Interfering means that if we uh, okay, let's take a look at this. Interfering means that both are kind of like against each other, and that if you want to combine the two, you may have to lose something there. You may have to lose something here and there, but it is still possible. You just need a compromise. Non-interfering means that these two get along with each other very well, and it means you could just combine them directly, and both parties would be really happy about this. And finally, we have inclusive means that one of the requirements is already included in another, and that means hang on, one requirement already includes another, which means that you can just finish the parent, and the child one will be satisfied as well. So how do we resolve conflicts? There are four ways. You can negotiate. You can like disregard the other parties and just get into the competition. You may seek outside sources like maybe some judicial, extrajudicial, or like some maybe some maybe some arbiter in the uh, who can help who can help who can help like provide a third party input to the mix. And finally, we can do bidding and bargaining, which means you list out the terms that all sides want, and then we can search for a way to satisfy we can search a way to satisfy all parties through some kind of integration. So that is resolving conflicts. And how much time do we have here? We have about 20 minutes. Okay. So the last one we're going to look at here is goal analysis and modeling. Um, so what is a goal in requirements in the world of working with requirements? We have it means we it means the objective. Uh, it means the stakeholders' objective for this system. Like, what does the stakeholder want in this system? This may include the software aspect and its surrounding environment. Now, when we work with a goal model, we try to build a nice hierarchy of the goals to work with. And if we do goal modeling, we can use it to help resolve conflicts. Basically lay out like which requirements hurt what and what we're gonna do about that. Here's the thing though. If you're gonna do goal modeling, like notice that like goal modeling only takes a nice little snapshot, take a nice static snapshot. It doesn't change. It's like a photo. And that goals do change over time, so you may have to take multiple snapshots. So we've learned a particular way of doing goal modeling called the I-star notation. Um, you can take a look at the different symbols used here. I think in lab 3 we're gonna focus on both, but from what I read, I think it's more like the bottom, which is the strategic rationale diagram. But I think you may also consider both. But yeah, I think I read more on the SR diagram. Do let me know what's on lab 3 though if I'm wrong on that. Okay, so there are different types of goals that we looked at. We have the functional or the hard goals, so you have to carry those out fully. And then we have the non-functional or soft or fuzzy goals, which are not easy to define, and you don't have to satisfy it fully. Okay, so when it comes down to modeling goals, you may have to work with refinements. There are two types of refinements that we have here. We have the and refinement, which means that the sub goals are required for the main goal to be accomplished or achieved. And for or, it means that either one can be achieved, or you can also do both, and the main goal is would already be satisfied. It's a little bit like AND gates and OR gates. Feel free to look at digital systems for that if you don't know what those are yet. Okay, finally, we have something about contributions between goals. So when we deal with contributions between goals, um, we're pretty much taking a look at relationships between maybe a pair of goals. Actually, pretty much a pair of goals. For example, if we add new tracks, it does cost money, so it may hinder the goal of minimizing development costs. If we want to increase if we want to pretty much improve safety, I think you might have automate collision avoidance. You can add a automatic collision avoidance system into the existing train stations, and you may also that would help in improve safety. So one plus means that one goal will help achieve another, like they help but not completely. Minus means one goal will hurt achievements of another. It's like hindering it, but not entirely blocking it. Two pluses means once one of the goals are achieved, the other one also be the other one will also be achieved. So one goal guarantees the achievement of another. Let me write this down a little bit better. Oh, hang on a moment. Oh, whoops. Hey, okay, sorry about that. That is a little bit embarrassing. I had to reshare my screen a little bit. So hang on a moment, people. One moment. Okay, so let me just go ahead and put up my projector, and then my Zoom can capture that. Okay. Okay. Okay, we're back. So I actually would like to just go ahead and I would like to go ahead and actually just exit the slide. I'm going to write achievement of another. There you go. So for the plus plus, I actually made a nice little I made some like English related mistakes here. So for two pluses, achieving one goal will guarantee the achievements of another. So if you add new tracks, you can serve more customers. If you increase train speed, you can serve more customers. If you get more, if you run more frequent trains, you can serve more customers. Yeah. And finally, Two minuses is the opposite, meaning that if you choose one goal, you're going to block the other. There's not really so basically it's kind of like an either or scenario. I don't really have a double minus example here, but there will be scenarios where this will happen. Okay, and with that, here's how you analyze your goals. You define your soft goals first, and then you define the hard goals you can find from those soft goals. And finally, you evaluate the contributions from the diagram we had in the previous slide. And with that, we're done. Um, Thank you very much, everyone, for coming tonight. And if you have any other questions, feel free to let me know. Thank you. And good luck on the midterm. By the way, there is a midterm review tomorrow. Don't forget. Yeah. Thank you. Thank you, everybody. Thank you. Thank you.
Recording stopped.